All right. So this is our second example on integration by parts. And if you have missed the first video again, we are going to utilize the LIATE as our means of identifying which part of our integral will become our u. And once we have identified our u, that means the order of our selection will be, the priority will be the logarithmic function, inverse trig, algebraic, trigonometric, and exponential. And once we have set the u part of our integral, everything in the remaining component of the integral will simply become your dv. All right. And again, integration by parts is simply taking whatever integral you have, you express that in terms of u dv, and then that same integral will just be equal to uv minus the integral of v du. Now over here, our integral is the indefinite integral of ex cosine of x dx. Now if you remember, we're going to use the LIATE to set which part of the integral will become our u. Now the order tells us that we have to select the logarithmic first. That's L. Now an inspection of our integral, we don't see any logarithmic expression or function there. The next order of priority is the inverse trig. We don't see any inverse trig, right? So we move on to the next. The next one is algebraic. We don't see any also. And the next algebraic is the t, or the trigonometric. Now upon inspection, we notice that we have a trigonometric term here, which is your cosine of x. So that is telling us that I'm going to set my u to be the cosine of x. So that's one order done, one business done. And we'll just simply get the derivative of u. And that tells me that that is, if you remember, the negative sine of x. Now, I've mentioned earlier that once you have set which part of the integral is your du in this case, your u in this case, the cosine of x, everything that remains in your integral is your dv. So in this case, it's very clear that my dv is given by e to the x dx. And we like to integrate this one. I'm going to integrate both sides to get v. This tells me that I will get v is simply, of course, I really like to integrate e to the x because that will remain as a to the x. Now I know there will be plus c since this is an indefinite integral, but for now I'm going to remove that for simplicity, but that will come up later. So base from here, we now have identified our u and our v, and so is our du and other things. So we can now utilize the integration by parts, this one. So that means to say that this one is my u and this one is my dv. And this tells me that u dv should be just equal to u times v, which I know already, minus the integral of v du. So that means that the integral above will be re-expressed as like this. U, okay, we're going to deal with u. U is just the cosine of x. Multiply that by v, and our v is just e to the x. And the next one is minus the integral of v. Now v is just e to the x, and then du. Our du is negative sine of x dx. Alright, so I'm just going to rewrite the first term as e to the x so that I will not be confused. Cosine of x. And this one, the negative sign over here, if you notice the negative and negative, that will multiply to form a positive. So that will just be positive of e to the x of sine of x dx. Now, this is one of those cases where you have to do integration by parts multiple times or n times. In this case, notice that this portion of my integral is not that simple. So I will use integration by parts again in this case. So the LIATE that we mentioned earlier still holds in this case. So the order will still be the order for u, priority of u is still logarithmic, inverse, algebraic, trigonometric, and exponential. Now, upon inspection of your integral, the same case actually is applicable here because the order is telling you the first uh, the priority for you is t, trigonometric, because you don't have logarithmic, you don't have inverse trig, you don't have algebraic, you have trigonometric. So that means that your u will be the sine of x. And the same thing with what we did earlier. We take the du, and du is simply the cosine of x. Now, everything that remains, since this one is our u, practically everything that remained in our integral is our dv. In this case, it's the e to the x dx. Now I'm going to integrate again both sides to get v. So I'll get v is simply equal to, and my god, I love to integrate e to the x because that's just e to the x plus c. But I'm going to leave out c for now. So that means to say that this portion of the integral can be further expressed in terms of, this one. So we will have, I'm going to copy e to the x cosine of x plus u, right? U. So our u is sine of x, and the next is v. Sorry, I should have written it there. V. Our v is e to the x. And then we have minus the integral of v. Our v is e to the x. And du, our du in this case is cosine of x. Alright. Now this looks very interesting because if you notice, there's an integral that repeats itself. But I'm going to simplify this first. I have e to the x cosine of x plus, I like writing everything before the cosine and sine so that I will not mistake it for the angle, sine of x. And then this is e to the x cosine of x dx. Now friends, I'm hoping you notice that this term here, the e to the x cosine of x dx, is actually just our integral. So this is telling you that if I'm going to actually write everything, this is just e to the x cosine of x dx is simply equal to e to the x cosine of x plus e to the x sine of x minus the integral of e to the x. I have to move this here. Okay, e to the x cosine of x dx. I can actually take this part, this section of my expression here, and move it on the other side. Sorry, it looks weird. Move it here. So when I do that, I will get integral of e to the x cosine of x dx. I have negative, so when that's transposed to the other side, that will become plus e to the x cosine of x dx. And everything that remains, I will factor out e to the x. So I have cosine of x plus the sine of x. Now notice that it's just like a plus a, we know that to be 2a. So the same thing happens here. You have two exactly the same integral. So you have two of the same integral, ex cosine of x dx is equal to e to the x of the cosine of x plus the sine of x. Now take note that what we're actually looking for, I know this looks very messy now, but what we're looking for is this integral over here. Now, upon our solution, we have reached to this part, But what we are looking for is simply this part, right? This one. What does this equal to? So to do that, then I could simply manipulate this one so that I will simply get whatever is this here. And clearly I can do that by multiplying both sides of the equation by, of course, 1/2. Because if I do multiply both sides of the equation by 1/2, this will cancel out, and leaving us with the integral of e to the x, cosine of x dx, which is what we want and what we are looking for in the first place. So that means then that 1/2 will be multiplied to the other side. This will become 1/2 of e to the x cosine of x plus the sine of x. Now remember the c that I've mentioned earlier that I keep on omitting, so everything is subsumed under this plus c thing here. So this should be the solution for this integral using integration by parts. Now I'm just going to recall, you don't have to worry if you're seeing exactly the same integral again, just like what we did over here, because that's actually a good sign. It's easy to manipulate if you're getting in your solution the same exact integral that you're looking for. You just have to move that to the other side and just like do it like a plus a, that will become 2a. All right, so that's it for the second example of integration by parts for indefinite integrals. Up next is integration by parts for definite integrals.